Okay, today we're going to talk about igneous rocks. Igneous rocks form when magma or lava cools and makes crystals. Intrusive igneous rocks form in the ground or underground, hence intrusive in the ground. This is where the magma cools really, really slow and you get large crystals. Like you look at the rock and you can see the crystals. Extrusive igneous rocks form above ground. They've exited the earth. Extrusive, exit. When this happens, the magma cools really, really fast, and you get teeny tiny crystals that if you can see them, you question whether you can see them. They're really small. Oops, let me move that for you. There are volcanic igneous rocks that form from molten rock that cooled quickly on or near the Earth's surface. Okay, and plutonic igneous rocks that are formed far beneath the surface of the Earth, forming rocks with large, large crystals. So volcanic igneous rocks are extrusive, plutonic igneous rocks are intrusive, or intrusive. Okay, we're skipping him for now. Okay, a pluton is classified according to its shape, size, and position in the surrounding rock. All a pluton is igneous rock that formed inside the ground, so intrusive, and the ground has weathered away around it, leaving what they call is a pluton. This right here is an example of a pluton. Part of this right here is a pluton also. Okay, igneous rocks can be classified according to their composition and texture. Composition is the minerals from which the rock formed from, and texture is the shape, size, arrangement, and distribution of the minerals that make up the rock. There are 4 textures you need to know. Copy what's underlined. We have glassy. Glassy texture is not necessarily what you think of. It is not like window glass. Glassy texture is just when you cannot visibly see the crystals. Obsidian, scoria, and pumice are all glassy. Aphanitic is like basalt. It's fine-grained, where you look at the rock and you're like, oh, I think I see some crystals. You can see something, but it isn't like a definite crystal shape. That's aphanitic. Phaneritic is like granite. So think of like granite kitchen countertops. These are coarse-grained crystals that are roughly the same size, and they tend to interlock, or they look like they're kind of smushed together. And then we have porphyritic. This is when you have a igneous rock that doesn't appear to have any crystals, and then all of a sudden there's big crystals on it. So it's large crystals scattered on a background of smaller crystals. This is glassy, that's obsidian. Aphanitic, this is basalt. Phaneritic, this is granite right here. And porphyritic, you see these big crystals on the background of small crystals. Okay, they are further classified as felsic, mafic, or ultramafic. This has to do with the color of the rock, like literally when you're looking at it, the color that you see predominantly. Felsic is light colored, which means it has a whole lot of silica in it. Silica, think of like sand. The more sand, the lighter it would be. Mafic is dark colored. It contains iron and magnesium. And then ultramafic has very low silica. It has a whole lot of iron and magnesium. Ultramafic rocks are very rare. Okay, and remember, the more silica, the lighter the color. Magma composition. Just copy what's underlined again. Okay, all igneous rocks are made of magma. The silica content affects the melting temperature and impacts, oh, I wonder what this says. Oh, okay, and it impacts how quickly the magma flows. There's 3 types of magma. There's basaltic, andesitic, and rhyolitic. You just need to know the names. You don't need to know the silica content. Basaltic makes basalt. Andesitic forms andesite, and rhyolitic forms rhyolite. The main factors involved in the formation of magma are temperature, pressure, water content, and mineral composition. I'll show you that in class. Okay, veins. At the end of the crystallization process, so imagine that you have magma that is slowly cooling. At the end of it, before all of it cools, there's kind of like sludge left over, okay, or it's mineral-rich fluid, and that fills in little cracks and little voids in the surrounding rock. The fluid solidifies and it can form veins of gold or gems or other rare minerals. You need to know what's underlined, the pegmatite and kimberlite. Pegmatites are veins of extremely large-grained minerals. They generally form gemstones. Kimberlites are only found in rare ultramafic rock. Generally, it forms really deep under the earth and under a lot of pressure. This is where you find diamonds. So if you're out there and you want to be some sort of gem hunter, if you're looking for the pretty gemstones like the amethyst and the quartz and the sapphires, you're going to look for a pegmatite. If you're out there looking for the diamonds, you're going to look in a kimberlite. Okay, look at the rocks, read about them. These are the specific ones you need to know. You do not need to copy any of this. Okay, granite, it's right here. It's used for long-lasting monuments, trim and decoration on buildings. Scoria is right here. It has like little holes in it. Pumice is either dark colored or light colored. You can see it both ways. Sometimes it's even like a tan or a peachy color. Pumice forms right above the ground. It is extrusive. Let me move that for you. It's really, really light when you hold it. And obsidian is really pretty. It used to be used for arrowheads. Okay, I want you to write the answers to these questions. This is the only thing I'm going to be collecting from you. Maybe I can make this so you can see it. There you go. So the only thing I'm going to collect from you are these questions. So if you could put them on like a half sheet of paper, that would be great. Okay, the first one. What characteristics are used to classify igneous rocks? Number 2, how are intrusive rocks similar to extrusive rocks, and how are they different? Number 3, what determines the size and types of crystals in rocks? Number 4, what is the relationship between a rock's texture and where it was formed? And number 5, what feature is most likely to contain diamonds? Have a good weekend.